In this video, we're talking about electron configurations of monatomic ions. That's just ions, things with electric charge that have just one atom in them, just not molecules. So let's look at lithium and the lithium cation. A cation is something with an overall positive electric charge. And the way that an atom has a positive electric charge is by losing electrons. So this represents the nucleus with the protons in there. I'm not showing any neutrons yet. And lithium has 3 protons. Any atom that has 3 protons is a lithium atom. And a neutral lithium, you can tell that this is neutral because there's no charge here, has the same number of electrons as it does protons. Each one of the negative charges that come from an electron is canceled out or cancels out a positive charge from a proton. So if we have 1 electron for every proton, then all the charges cancel and there's 0 charge overall, and it's a neutral atom. Now, if we take one of these electrons away, instead of having 3 electrons, we have 2. We still have 3 protons because it's still lithium, but now one of those positive charges isn't canceled out. So overall, we have a positive 1 charge. This electron and let's say this proton cancel, and this one cancel, but one of these protons doesn't have their positive charges canceled, and so we get a +1 cation for lithium. If we were to take 2 electrons away, we would have a +2 cation, and so on. When we make anions, it's just the opposite. We have to add electrons. So a neutral fluorine atom has 9 protons, represented by the 9 positive charges in here, and it also has 9 electrons because all the electric charges cancel. Same number of electrons as protons in a neutral atom. Electrons as protons. So we have 9, hopefully there's 9 electrons here. And if to make an anion, what we do is we add an extra electron, or 2 or 3. In this case, I've added 1 extra electron, so there should be 9 positive charges and 10 negative charges from the 10 electrons. 9 of these electrons have their negative charges canceled. 1 doesn't have it canceled, so overall there's a -1 charge, and it's a fluoride ion. If we had 2 extra electrons, it would be 2-. When writing the electron configuration for a cation, we're always going to start with the neutral atom and take 1 electron away for every positive charge that we have. And here's the thing, remember this. When you remove electrons from a neutral atom to make the electron configuration for a cation, always take the electrons out of the highest occupied level, N, or shell. So for example, with magnesium +2 cation, then we start with the neutral element. Magnesium is 1s2, 2s2, 2p6, 3s2. The highest level, remember the level or the shell is given to you by the number in front of the letter, so it's 3 right here. 3 is the biggest number, so these are the electrons that come out first. So we need to take 2 electrons away because it's a +2 charge, and that means that these 2 3s electrons come out, and we're left with 1s2, 2s2, 2p6 as the electron configuration for the magnesium +2 cation. Aluminum. So now we're going to do the same thing with aluminum. We'll make the +3. A couple things here. So aluminum, the neutral aluminum's electron configuration using noble gas notation is neon 3s2, 3p1. The highest shell or level that's occupied is the N=3 shell, and they include the 3s and the 3p, the 1 of the 3p. So we take 2 + 1 is 3 electrons out, and we're left with the aluminum 3 cation. Now notice we don't write just neon. We always go back 1 previous noble gas when we're using noble gas notation. So we go back to helium and write 2s2, 2p6. Now, iron with a +2 charge. Well, the neutral iron atom is argon 4s2, 3d6. Now watch, even though the last electrons that we put in were the 3ds, the highest shell or level that's occupied is the N=4 level. So we're going to take the 4s electrons out before we take the 3d. So iron 2 would be argon 3d6. If it was iron 3, now we take one of these out and it would be argon 3d5 for 3+. Making anions, we just, again, start with the electron configuration for the neutral atom and just then start adding more electrons following the same order of filling that we would normally for any atom. Just adding the number of electrons as we have negative charges. And here the fluoride ion has a -1, so we're going to add one extra electron. The neutral fluorine atom's electron configuration is 1s2, 2s2, 2p5. We still have room for one more electron in the 2p subshell, so we write 1s2, 2s2, 2p6 for the fluoride ion. Now note, if we wanted to make this a 2 negative, we couldn't put any more electrons into the 2p subshell. We'd have to go out to 3s and write 3s1 after that.